Okay, so the lab experiment that we're going to conduct is called the lava lamp experiment. And so the materials that we're going to be using are 3/4 of water in a bottle, Alka-Seltzer, and vegetable oil. And sorry, I do not have food coloring, so we're just going to have to complete the process with these 3 types of products. So first, I added 3/4 a cup of water. And now I'm gonna pour. A whole bunch of vegetable oil all the way to the top. Okay. So as you can see, both liquids are both compacted, and so water has less density than the oil. And so after that, I'm gonna add the Alka-Seltzer. So we're gonna crush these up into little pieces. As you can see, pour it in, and as you already tell, it's dissolving. And as you see the fizzing, as you can already tell, the experiment is already working, causing. So as you can see the little pieces of Alka-Seltzer dissolving, it's pushing it up. So my hypothesis would be is that when these items are mixed, they will give a lava lamp effect. The oil will float on the water, as you can see, and the Alka-Seltzer tablets will sink to the bottom as they did of the container, and when it fizzes, it will create a lamp effect. And so the data that I discovered, as you can see, is that the oil did flow out of the water because the water is less denser than the oil, and that's why even though they are both liquid and water and oil do not mix. So the Alka-Seltzer tablets contain citric acid and sodium bicarbonate, which is a baking soda. When I place the tablet in the water, the acid in the baking soda reacted, forming carbon dioxide with its, which is fizz, that is responsible for giving the lava lamp effect that the fizz from the tablets made the water move through the oil, creating the lamp. The density of the liquid sinks to the bottom, but the lava lamp heats it up and expands it and becomes less dense, causing the rise upward. And as it gets farther through the light, it cools down, becoming more dense until it sinks, and the cycle starts all over. Instead of using light, we created a homemade lava lamp using Alka-Seltzer to power the lamp. The Alka-Seltzer reacts to the water, producing carbon dioxide gas bubbles that stick as water disposals. The water gas combo is less dense than the oil, so they rise to the top of the flask. At the top, the gas bubbles pop and escape in the air, allowing dense water to sink back to the bottom again. And so when we added the tablet piece, it sank to the bottom and started dissolving and creating gas. And as the gas bubbles rose, they looked some that colored water with them. When the bottled water reached the top, the gas escaped down and went to the water. And so together, to the similar its magnets and attached to each other, oil molecules are attracted to the other oil molecules that get along as well, but the structures of the two molecules do not allow the bond together. But of course, there is not a lot of fancy scientific language to describe density and molecular polarity, and maybe at least that the vinaigrette salad dressing is a whole different way.